Okay, so we stay on time. Our next speaker is the presenting company. Our next presenting company is TiCARos, and presenting for TiCARos is Daniel Kim, who is the Associate Director of Business Development for TiCARos. Daniel.
Thank you. Good morning. First of all, I would like to thank Bio and JLabs for this great opportunity. I'm very happy to introduce our company, TiCARos. We deal with CAR-T therapeutics, and we utilize with unique proprietary CAR-T platforms for the next generation CAR-Ts. Just a bird's eye view of our company. We have three core proprietary technology: clip, converter, and switchable. And by utilizing that, we have TCO11, which is in the phase 1 right now in 6 major hospitals in Korea, just finishing up our low dosing regimen group. TCO31 and 091 are both targeting solid tumor by the CAR-T therapeutics. So our main mission is to develop a solid tumor targeting CAR-T. As you're familiar with, the solid tumor accounts for about 90% of all tumors globally. And however, all approved CAR-Ts, to be exact, 6 of them today in the commercialized CAR-T market, they're all focused on hematological malignancies or blood cancer. So development of the solid tumor targeting CAR-T therapy will be a crucial and also will open up a tremendous market for the CAR-T therapeutics. So in order to target a CAR targeting solid tumor, we have came up with 3 proprietary technology: clip and converter and switchable. Mainly, we'll be talking about clip and converter technology for today. So this system, as you're very familiar with, is the basic construct of the CAR-T. We have a binding domain, it's a single-chain antibody, hinge, transmembrane domain, and signaling domain. And the most simple way to modify or enhance the construct is maybe to alter the binding domain of the single-chain antibody. And the global efforts has been going on with the exchange or switch of the, or addition of the signaling domains such as CD28 by Gilead, 4-1BB by Kymriah and Novartis. However, not many global efforts has been going on with the transmembrane domain modification, and that's where we found our niche. Our scientists have identified this very unique transmembrane domain that could potentiate the immune synapse for the carrying out of the therapeutic activity for the CAR-T cells. And since we're not dealing with the extracellular binding domain, nor the intracellular signaling domain, there's a lesser chance for us to have a manipulation of the mechanism. Quickly about the immune synapse, it's the binding region between the lymphocytes, such as T cell, and the target cell, such as APC or cancer cell. And by switching these transmembrane domain into our clip technology, we can expect the expansion or the stretch of the cytoskeleton, which allows the CAR-T cell to have a wider and a tighter formation of the synapse to bind to the cancer cell. First mode of action data we have looked at was the actin and tubulin co-localization. Both are very key components for the formation of the cytoskeleton, or in other words, immune synapse. You can see with the clip technology applied, we have tubulin and actin very well co-localized, whereas the non-clip condition has shown a poor localization compared to the clip applied condition in the T cell. We have imaged these images as well and quantified it that allow the stronger binding affinity with the longer longevity of the engagement as well. We do have tremendous data. This asset is in fact in phase 1 right now in Korean hospitals. But this is a representative data that both in the low and the high dose, we have seen a significant reduction of the cancer just within the 14 days. And also, these 2 models actually survived all the way up to day 90 for this GLP efficacy study. What's more interesting is that this time we have lowered the dosage 5 times more or less, which means it's a subtherapeutic level for many commercialized CAR-Ts. And we have repeated these studies more than 5 times for the validation of the reproducibility study. And it shows the significant efficacy with 5 times less dosage. So it shows that clip technology actually indeed works in a low dosage as well. So with this very interesting platform, this time we have chosen a very unique target called MUC1 in order to solve the on-target off-tumor toxicity that exists in the solid tumor today. On-target, on-tumor toxicity could be somewhat alleviated by the antibodies like tocilizumab or Actemra as we know it, but on-target off-tumor toxicity is still a big problem in solid tumors today as a CAR T therapy. So quickly about the characteristic about the MUC1. It is overexpressed in the variety of solid tumors such as breast, pancreas, and liver. And this blue string line that I'm addressing right now is the backbone of this peptide MUC1, and there are VNTRs, which stand for variable number tandem repeats, that repeats itself on this backbone 25 to 125 times. So which means there's rich binding partners existing on the backbone of this peptide. However, in the normal condition, as such as in this case, the heavily hyperglycosylated MUC1 is widely expressed, and it forms like a mesh-like structure in the epithelial region, acting as a physical barrier for the binding partners that cannot penetrate through this glycolization. However, in a tumor condition, the significant decrease in the glycolization happens, or in the state of being hypoglycolization, and enabling a wider exposure for the binding partners to penetrate to this target. So we concluded that targeting MUC1, peptide of the backbone, is crucial to overcome an on-target off-tumor toxicity. So far, we have looked at stomach and pancreas cancer as an in vivo model. Right now, we are also doing a breast cancer model to further validate our in vivo efficacy of our MUC1 targeting CAR T clip applied. Next one is actually my favorite technology that our company has. It's a converter technology. Just very briefly about the background is that CTLA-4, as you know, is a inhibition or the immune checkpoint for the CAR T to inhibit the activity for the CAR T cells. The ideal way is to have a CD28 bind to B7 to eventually activate the CAR T cell to carry out its therapeutic activity. However, in the solid tumor microenvironment, the binding affinity between CTLA-4 and B7 compared to CD28 actually gets much more stronger, about 50 to 100 times more stronger than the normal condition. So what we did here is that we have retained or kept the CTLA-4 in the extracellular binding domain, whereas we have positioned the CD28 in the intracellular signaling domain, which means we can harness the CTLA-4's strong affinity with the B7, at the same time converts that negative signal into a positive CD28 signal to eventually activate the CAR T cell. That's why we call it a converter technology. And to validate the platform, we have firstly had a very conventional condition comparison study with the Kymriah. As you can see, the Kymriah itself had a reoccurrence condition and no survival group on the day 98, or actually the animal died within the day 40. However, the Kymriah applied with the converter technology not only showed a significant tumor reduction just within the 14 days of injection, but also up to day 98 until the sacrification of the animals, we have seen 100% survival. So now moving on to targeting solid tumor. This time we are targeting B7H3. I'm pretty sure some of you are familiar with this target. It is very richly expressed in solid tumor, especially they're at the same time very richly expressed in the tumor stromal cells, such as intratumoral vascular endothelial cells. So we believe that this could be a promising target to overcome a tumor antigen heterogeneity. Just a representative data here with the bulky breast tumor. And one interesting thing is that we have utilized with the Syngeneic mouse model, not the NSG. NSG mouse model could be somewhat exaggerated in the CAR T in vivo model for the exaggeration of toxicity and the efficacy. However, in the Syngeneic model as well, with the converter technology, with the certain interleukin that we have utilized, we have seen a complete regression in a bulky breast tumor. Toxicity as well, we have seen a transient recovery of the body weight towards the end of therapeutic approach. At the same time, a retainment of the body weight change within 10%, which means that it is a controllable toxicity for many commercialized CAR Ts today. As I mentioned, our TC011 are being conducted in Korea in 6 major hospitals. TC091, a MUC1 targeting clip applied solid tumor targeting acid, and also TC031, B7H3 targeting solid tumor acid as well, are on the IND enabling phase right now. Quickly about the global BD activity so far. We have this April, we have made a co-development agreement with this car NK expertise company, TiCARos. They also do have an experience to license in one of the car assets from Korea, so we believe that we are going to have a great synergy. They are experts in the car NK and will be providing our click technology. And also this December, we'll be seeing our first cytotoxicity data with our click applied car NK. So we're very excited to see the further exploration. We are actually started a collaboration of glioblastoma targeting CAR T with a major institution and hospital in US. It's called City of Hope. They have their own very unique glioblastoma targeting single-chain antibody, where we will provide also a clip for the glioblastoma collaboration. One of the main reasons why I could see the beautiful people and to present my company is because of J-Labs Korea. We were nominated as J&J J-Labs Global Innovation this year. So thank you, J-Labs. We love you. So let me just quickly mention about the situation in Korean CAR T market today. There are 6 commercialized CAR T therapies today approved. However, only Kymriah is available in Korea due to regulatory or the insurance reason. I'm a personal big fan of Novartis' Kymriah. It's a pioneering CAR T therapy. However, it has some room for improvement, such as Kymriah has complete regression less than 50%. The relapse condition, which one of our mission is to overcome the relapse situation, is more than 30% actually. And due to being an autologous CAR T therapy, it is a bit more pricier because you need to go back and forth to from the manufacturing side to the patients. So if we can occupy the 30% of the pie that Kymriah is having right now in domestic Korean land, this could be a handsome amount of cash cow for a biotech like us. And as you are very familiar with, after the phase 2 of the CAR T trial, we can obtain a conditional BLA, which means that it will be on the market ideally by the 2026. Of course, the solid tumor CAR Ts are our main asset that we are collaborating apart from our platform technology. So TC-091 and 031 are available, and they are actively being discussed by many partners. So as we approach to the next level of the critical phase of our development, we are targeting, we're almost third, fourth of the target investment. And this capital will be instrumental in fueling our operations through the commercialization of the TC-011, which are in the almost halfway in the phase 1 right now. And also it will serve as a support of for our IND approval for TC-091 and 031. This strategic investment will ensure that we are well positioned for the growth for the next 2 or 2.5 years. And very happy to talk to you guys after or during the bio, and thank you very much.